In the comparison, we saw the dipole moment of cis and trans isomers are different. Let us look at how or why they are different. If you look at the dichlorobutadiene, here one chlorine is let us say pointing upwards, other chlorine is pointing downwards. So, that means from the center, if you look at, one electron withdrawing group is pulling the electron towards itself to the top, another chlorine pulling the electron towards itself at the bottom. So, that means these two cancel out each other and we end up with a 0 net difference in the polarization of this particular molecule. So, that is the reason the trans isomers show 0 or less dipole moment. Whereas, if you look at the cis isomer, both the chlorine atoms are pointing in the same direction. So, that means this side we have a methyl group at the bottom. So, this methyl group is having a plus I effect, whereas the chlorine is electronegative in nature. So, that means it will pull the electron towards itself, making a charge polarization in this particular molecule, which leads to a dipole moment for this particular molecule. That means, cis isomers having both the electronegative group in this particular example on the same side lead to dipole moment for this particular molecule. So, that means cis isomer will show dipole moment, whereas the trans isomers generally do not show dipole moment. So, here let us look at the stereochemical notation. As we have seen earlier, in the cis isomer both the groups are on the same side, and in the trans isomer they are on the opposite side.